biting your nails, man. Is that the sign of?
I'm just doing I'm fixing my beard before we go live.
Okay. Let's see who we have. Whoa, man, we have a lot of people. Okay, 12.
Yeah.
12.
Okay,
Okay.
Fabian, we'll just give it a try first with Mahboob to share his screen, as he will be the first speaker.
Yeah, sure. Okay. Share my entire screen. I hope I'm not sharing my bank account details.
Oh man, I don't mind that, man.
Okay, let me know if you are able to see my screen. You can see my screen, right? Okay, am I audible?
I don't see anything.
Yeah.
Do you see his screen?
Okay. Yeah, it says I'm presenting.
Oh, okay. Yes. Chrome. Yeah. I was thinking, is that Mo's screen? Where he's looking at Google Chrome.
Yeah, I will share first my screen, guys. Then we can share Mahboob's screen. Okay. So yeah. So let me share my screen now.
I'm going to stop.
Yeah. Okay, Fabian, can you go on mute, please? Okay. Hey guys, so hello everyone to our October meetup. This is this year will be ending soon. So my name is Muhannad. I'm a solution architect working with Astro, and I will be your host for today. And before we get started, we will just start with some call outs. So our meetup today is on Google Meet, so please mute yourself when you join if you are not talking. And please don't forget as well to drop your question if you are following us on YouTube or on Meet. And the speakers will pick it up later after the talk, and they will answer your question. And today we have a giveaway AWS credits, how it will work. So our speakers will ask some question, and you guys can comment your answer, and we will pick up someone to get the credits, okay? And after the meetup, we will stop the live on YouTube, and we can just hang out together, just a networking session. You can ask any question, or if you have any problem with AWS, the community can help, okay? So today we have two special speakers, one from my favorite company, ServiceRocket, and Mahboob from Deloitte. So we'll start with Mahboob. He's a DevOps specialist at Deloitte, and he will share with us about EKS, a design consideration. And I will pass it to you, Mahboob, from here, and good luck. So you can now present your screen.
Thank you, Mohammed. Let me present my screen. And you may have to confirm again if you are able to see my screen. Okay, can you see my screen?
Yeah, can you share the slides?
Yep, yeah, okay, switching to my slides. And in my screen mode, okay, here I am. Hello everyone, my name is Mehaboob Basha. I work for Deloitte Consulting as a DevOps specialist in my current role. I've been working in the industry for over 9 years now across BFSI, oil and gas, and LMS domains. I mostly do building of cloud native applications and resilient infrastructure, and use several public cloud providers such as Azure, AWS, and Google, but AWS being my favorite and my area of expertise. I mostly do design, develop, build, and that's the area that I am closely inclined towards enjoying the most. I hold several AWS certifications and 1 or 2 Azure certificates, but mostly AWS, SysOps, and 1 professional level. When I'm not working, I'm mostly reading, and I do deep contemplation and a lot of retrospection. So sort of a philosopher. The agenda for today is mostly around the design considerations for production workload for EKS, but we'll touch base some of the things of what Kubernetes in general is, what are the core components. Then we'll touch what is EKS, different types of EKS, deployment, EC2, that is self-managed and managed, which is Fargate, and some of the downstream services that you can integrate EKS with. And the main topic for today, the design consideration in depth. What are the different applications that you need to get started with when you're considering to migrate your applications to EKS? What are the environment type that you have to get started with? And if you have to bring in high availability, what are the considerations you need to make? And what are the downstream services that you can integrate with? How you can scale in, scale out? What is ingress controller, how you can bring in ingress controllers, and what are the different options and challenges that you will face and you need to consider. Then we will go through demo. It's not important demo per se, because the important thing that I'm trying to drive here is the design considerations before you even start building stuff. So demo is just to click those buttons and walk you through how it is done, but Amazon's documentation is far better than what I have done and what I'll show you. Right, and then we'll clean up the cluster, whatever we have created so far, including the CloudFormation template. Mohanad, during the presentation, they can ask questions, or you said in the end?
Actually, you can. Depends on how do you think. Yeah, you can ask in the mid, and we can pick up later or at the end. So that should be fine.
Yeah, is it verbal or is it chat-based, Mo? Can I jump in midway and say, "Hey, bro, can I ask a question?"
No, it will be on chat. Yeah.
Okay.
The answer. Yeah. Unless it's at the end of the talk, we can ask question. Yeah.
Okay. I'll refrain myself. Thanks.
Thank you. There are some prerequisites, like most presentation. You need to have understanding of what microservices are, what containers in general is, and what containers in general are, how do you manage them. If you want to follow along what I'm doing, maybe just clicking through the buttons and looking at the various options, you need to have AWS Management Console login and AWS CLI if you want to run the commands which I'm running, and kubectl CLI on your computer, and programmatic access to make API calls to AWS services. So these are some of the prerequisites. The first question before you hit manage Kubernetes service by Amazon is, why do I need to go to Kubernetes in the first place, right? There was a survey done by CNCF, which manages Kubernetes now after Google outsourced it, or rather open sourced it. Like almost all of them said they're running containers on production in some form, and 80% of those same surveyed people or surveyed businesses also said they're using Kubernetes. 80% of the same thing, they said they're using Kubernetes because of its portability and scalability. And almost 50% said they're running 250 containers, which means like they are having containers in production, and hence they need a solution to manage these containers. Now, around 100,000, this was some time ago. Now it's around 100,000 commits on GitHub. That itself is a testimony to why it is so popular. Now, EKS in specific, because of its saving on resource allocation and hardware cost, because it's a managed service, and who is using EKS or managed Kubernetes, including Amazon. Amazon.com itself has some of the services hosted on EKS. Then you have Snapping, HSBC, GoDaddy, and so on. That should give you a pretty good idea of why Kubernetes is so famous and why companies are after easing it out for the businesses to deploy and use Kubernetes. So I'll just give you a walkthrough of what Kubernetes is. Kubernetes is divided into two main components, that is a control plane component and a worker plane component. Now the control plane component consists of kube controller, kube API server, scheduler, etcd, and manager, right? And your worker plane component consists of your kubelet and kube proxy. In essence, Kubernetes is nothing but an orchestration engine for managing your modern applications that are running as microservices, right? Now, you can create Kubernetes cluster, and Amazon is not the first to have created Kubernetes as managed service. You can have other options of deploying Kubernetes, like you can deploy it on physical servers, you can deploy on virtual machines and use cloud such as AWS and have virtual machines on top. Or you can use managed services like EKS or AKS by Azure or GKE by Google. Some of the things or the terms that you need to be aware of for this presentation are Kubernetes objects like pod. What is a pod? What is a service? What is a deployment? What are namespaces? What is a daemon set? What are replica sets? Now, pod is the smallest unit with respect to Kubernetes for compute, and services with respect to Kubernetes are the way of exposing these applications to the outside world. That outside world can be outside the cluster or just outside your compute. And deployment are your applications that you're deploying on the Kubernetes cluster. Namespaces are the logical isolations, nothing but your virtual clusters within a cluster where you logically isolate one application or one set of applications from the other. Daemon sets are nothing but a set of applications running in each node, and they can scale up and scale down based on your nodes scaling up and scaling down. Replica sets are the number of instances of your applications that you define that you want it to run during a runtime or during its life cycle. Till here with me, I will reiterate or ask some questions maybe at the end as to what it is the terms that we have defined right now. Okay, for the question and answer series kind. Now, EKS, the main topic for today, it's a managed service by Amazon. Like Kubernetes, you have two most important components. It is a control plane and you have worker nodes. On control plane, you have the same things such as controller manager, QAPI, scheduler manager, and etcd. And on your worker nodes, and this is self-managed, which means the worker nodes are VMs managed by you as a customer. And Amazon manages the control plane components, which is nothing but QAPI, scheduler, controller manager, and so on. You have two options of using EKS. One is EC2, like I said, self-managed, which is managed by you, and Fargate, where you don't have to manage even the worker nodes. Amazon does it for you. All you need to do is create Fargate profiles, just create your YAML files and dump it to EKS cluster. Then when it comes to high availability and scaling, we have two options, that is using autoscaler and autoscaling groups. Some of the downstream services that EKS integrates natively with is load balancers, Route 53, certificate managers, EMR, CloudWatch, and so on and so forth. Okay, this is our hero for today, that is the design consideration. The first design consideration, and this is all based on our experience of moving our existing production workload from Mesosphere's DCOS to a managed Kubernetes service. These are some of the lessons that we learned when we were migrating, right? Now, the first question is, should my cluster be accessible over the internet, or should it be accessible over only the corporate network? This is the biggest question that you have to answer before you get started, because Amazon says you have three options. You can go on private, public cluster, or you can have your worker nodes on private network and your control plane on public network, or you can have all three only on your private network. And each one has its own pros and cons, so you need to be mindful of which one to choose. It truly depends on your business case. But this is something that you need to consider before you start building your EKS cluster. Now, this is the application type. Which applications do you want to move to EKS from your existing container orchestration engine? Do you want to get started with your business critical application by going, like, say, moving 10 containers or 10 sub applications? Or do you want to get started with the non-business critical applications which are being used only by your internal employees before you do the heavy lifting of your business critical applications? We ended up migrating some of our business critical applications and had to roll back within a week. Hence, this thing came up in this second slide. And I thought we were just one of those who did not know this. There are many such people or many such architects which think or who think that it's okay, let us go with Delta, let us move maybe a business critical application, half of it. But even half, is it risky, not risky? go down on the path of understanding which one do you really want to get started with. Then the third most popular question when considering EKS is, do you want to have multi-tenancy or do you want to have applications running in a single cluster, EKS cluster? So what we ended up doing was having a single cluster, because we thought in our existing infrastructure, we had just one cluster, and we thought we should do the same thing when we are moving to EKS. Now, what that ended up doing was creating complexities when integrating it with the downstream services. So if you have applications which require their own network setup, which require their own downstream services, before you take the route of creating the clusters, just jot down what are the pros and cons of your business to move with multi-tenancy or without multi-tenancy. But an important aspect to consider is, should I have one single cluster or multiple clusters for the applications? The EKS deployment type, like I was saying, if you have applications that require or that mandate you owning the worker node. When I say owning, you managing it. Like you want to harden the image, you want to have logs shipped to your centralized logging system and probably mask several things. You also want to have the control over when to patch these servers, how often to patch these servers. If there is a regulatory requirement, then you have no option but to go for EC2. When you don't have such regulatory requirement and business cases where you are not forced to use self-managed EC2, definitely choose for Fargate. Easy to manage. There's no hardware, there is no operating system to patch when considering Fargate. So you need to understand your business case and make a decision accordingly. Then this is the fifth most important thing, which most businesses need to consider, is the integration with the downstream services. If you have EMR, and if you have EMR running in a different VPC and your clusters are running in a different VPC, how do you want to connect these two VPCs? Do you want to have a transit gateway in between, or do you want to route the traffic through VPC peering? If you don't want to do VPC peering and want to use transit gateway, and you are binding your EKS cluster to a domain of your own, say you are you have set up the EKS cluster in the private mode, meaning the entire cluster is private and running in your own VPC instead of running in Amazon's VPC. That means you get to choose the domain, you get to bind the FQDNs. So this VPC needs to talk to your EMR VPCs. That's when the complexity increases. So you need DNS forwarders, you need special DNS services and special hosted zones and all to establish connectivity between your downstream services if they are running in different VPCs. So before you start saying, okay, let me just for now create a cluster and these are my services, and you get started, you stop, take a moment, take a step back and understand what are the downstream services your application is using and which network will it stay in, and then get started. Secret management, do you want your secrets which your applications are using, do you want it to be cloud agnostic? For example, I have seen companies have Kubernetes cluster, one running on Azure, one running on AWS, okay, and one on-prem. When you have such multifaceted environments, hybrid environments, you want one location where you want to pull your secrets from. In that case, you might go to a third party like HashiCorp's Vault. Or if your clusters, you know for sure that they'll be running on Amazon and all your downstream services applications are on Amazon, you might as well use Amazon's either SSM parameter store or secret manager. But you need to take a long-term approach of how your applications are going to stay. Are they going to become multi-cloud? Are they going to become multi-environment? Are they going to stay on Amazon? If yes, you have options of using parameter store or secret manager or HashiCorp's Vault. This is by far the most important topic for deploying Kubernetes. I wouldn't say EKS per se, but EKS definitely. How do you want to take your application traffic outside of your network? you'll obviously be using Ingress controller, because this is the interface between the internet and your applications. So when you're using Ingress controller, you have several options. Like on the Kubernetes documentation, you will find, I remember reading at least 16 options. So which one makes more sense to you? Do you already have Nginx servers in your existing infrastructure and your engineers are familiar with the context rules that you create in Nginx? Do you want to use the same Nginx controller when you are migrating to EKS? That's one consideration to make. Or if you don't have Nginx server in your existing infrastructure and you're open to use a managed Ingress controller, AWS has its own AWS Ingress controller, and it is a managed Ingress controller which AWS has, which creates your load balancer and manages routes automatically. One caveat that we face, especially when using Nginx Ingress controller, is it does not create application load balancer by default. It creates only a classic load balancer. The problem with that, as you know, is you cannot do path-based routing. So if you have 10 microservices, for example, you want to go to microservice, say, cart for an e-commerce, you want to go to payments. So when you want to do that sort of routing, your classic load balancer cannot handle. So what we ended up doing was have an Nginx Ingress controller and then forward that Nginx Ingress controller to an application load balancer by creating custom rules that added to the complexity. So if you're someone who's just getting started or who's not bound to use Nginx's context and rules, by all means, switch to AWS Ingress controller. It simplifies. Then the other consideration to make is logging and monitoring. If you have an existing logging system like Splunk, you can definitely forward all your logs to Splunk. Splunk provides a Splunk forwarder. They have a service of their own which runs as a daemon set in your EKS cluster and forwards all the logs to your upstream Splunk server. For monitoring, you can use CloudWatch, you can use Prometheus, and there's one application by SolarWinds called App Optics for forwarding your alerts and monitoring the entire cluster. We ended up using a combination of Splunk, App Optics, and Datadog. It truly depends on how granularly you want to monitor your cluster. Cluster security, EKS gives you a lot of option and flexibilities with respect to managing the security, with respect to authentication. It natively binds with your IAM users and roles. And then it also supports LDAP integration, meaning if you have Active Directory services and you want to authenticate using your LDAP credentials, you can do so. Although it is complex and painstaking, but it is definitely supported. And once you finish this for whatever compliance or regulatory requirement, it is very fulfilling. But natively, if you want to just use IAM services, IAM users role creation binds natively with Kubernetes RBAC roles. Version controlling, you can have your Jenkins and your version controlling systems such as Bitbucket and club that with Helm and deploy it. But if your workload is totally on Amazon, by all means use Amazon CI/CD toolset to manage your deployment and delivery. But this is again, you need to make this decision based on your business use case. So far, any questions? I'll switch to the demo. What I had done is, since the EKS cluster creation takes anywhere between 20 to 45 minutes, I had just warmed up a cluster and I created the cluster before starting the presentation so that I don't waste anybody's time. So, Mohana, do you want me to go through the demo, which I think I should, but
yeah,
just to check the time.
Hey, Mo, can I ask questions?
Who's talking?
Hi, this is Fabian. Yeah, can I ask questions?
Related to the slides?
Yeah, absolutely.
Yeah, go ahead.
So hi guys, I'm Fabian, and I'm also a solution architect. Quick question on one of your design considerations. You mentioned about multi-tenancy earlier. What I gathered from there is like a cluster per app or a single cluster for multiple applications. Question for you, what are your learnings there? Are there any diamonds, you can share with us about that? How do you go about deciding?
Right. Like I was telling, it depends on the business use case. Having said that, for our use case, we started off with single cluster, thinking we will scale up my clusters, scale up our cluster, because we have autoscaler and Amazon gives auto scaling groups. So I can increase the instance type from large to extra large to memory optimized, whatever. I have flexibility there, and I can also increase the number of instances. So we thought that we can scale the cluster and deploy multiple applications there. But then as the complexity increased, we wanted to migrate more and more applications. We realized that it is better to have multiple clusters. That way you are reducing your blast radius and your complexity with respect to integrating with other downstream services. So if you are somebody who's having 10 different applications which are getting integrated with 5 to 8 different downstream services, start assuming that 6 months, 1 year down the line, you'll be spinning up far more clusters than you can imagine.
Got it.
So the lesson for you is start with multiple clusters and not multi-tenancy.
Got it. Okay. Just going deeper into that, right? You mentioned downstream integration. You had problems. Like, can you probably just share one point? Like what kind of integration problems do you run into? So at least get better visibility. What kind of problems you experience?
Right. Good question. Now my EKS cluster was in one VPC. Let's call VPC 1, and because I was migrating, I already had a workload, which means EMR was already existing. I'm just exemplifying with respect to EMR because that's the issue that I faced. So my EMR services were running in a different VPC. When we moved the application to EKS, spun up a EKS cluster on a specific VPC, integrating these two VPCs, as easy as it might sound, that you peer or use a transit gateway and the traffic flows. Well, the traffic might flow, but the applications don't behave the way we expect them to. We thought that the resolution of your services, for example, I have service.eks.com running on in my EKS cluster, and my EMR is running on, say, emr.aws.com. The premise that you would have is, as far as I have connectivity between my VPC of EKS and VPC of EMR, everything should work. Well, it was looking, the application was looking for specific nodes of my EMR, the connectivity, and it wasn't able to resolve and connect to the EMR. So what we ended up doing was have a conditional forwarder, have a custom DNS setup done so that the traffic, the endpoints, the FQDNs get resolved to the IP addresses, so that EMR and my EKS cluster can resolve each other's nodes to IP address and talk to each other over this common platform. So there was one important learning that we had. Hence, I was stressing on the point that when you're starting off, when you are integrating your applications, you need to understand how do you want to set up your networking. Do you want them all to be on gigantic one big VPC of a /16 CIDR and put everything under one, or do you want to have your downstream services running in their own VPCs and your EKS cluster, and then have one conditional forwarder in between, which takes care of routing this traffic?
Got it. Thanks so much. Very, very, very insightful there. And I think what I'm hearing here is that if, let's just say that I don't want to deal with this kind of complexity, one other approach I can take is that I can have the, let's just say that this is actually more for analytics workloads. You are running EKS for that purpose and you are using EMR, you can just put them inside one VPC and then probably that problem will go away.
Yeah. But okay. This is, again, this depends on the scalability, right? If your application is small, what you're saying, you can do that using a /16 CIDR because it can scale up only to X level. But then if you are having a business application with multiple services, it's going to grow out of proportion very soon. So you need to still figure out, should you have EMR in its own VPC and EKS in its own VPC. So it depends entirely on the size of your workload.
Okay, thanks Fabian for the input. Was very interesting. Mahboob, you can go ahead with the demo.
Okay, sure. Thank you.
Yeah.
So like I was saying, what I did was I spun up a cluster before we started the presentation, because it takes around 30 to 45 minutes to spin up. But this is my GitHub page. And I just did a debunk of Amazon's documentation. Like I reduced 30, 40 odd pages documentation to 12 lines of steps. Okay. So I just moved it to GitHub. So I'll copy from GitHub. I created a role already. I'm still going to create one. Go to create role. Choose EKS, cluster, next, and next, and next. So all these steps are here. Go to IAM role, create, EKS cluster, permission, name my EKS cluster. I had already created EKS cluster role, so I'm just going to make it 2. Create a role. Okay, so I've created a cluster role. Then the next step is to run the CloudFormation template. Copy my template. This template is available on EKS's documentation, but I'm still going to show you what all the resources it creates. It creates public subnets, 2 public subnets. It creates 2 private subnets. It creates a VPC, Internet Gateway, VPC Gateway, and it also creates 2 NAT gateways, NAT Gateway 1, NAT Gateway 2. Okay, and it binds this through route tables. That's this guy. Now copy this and go to CloudFormation. I will run it in Virginia. Create stack. I have my S3 here. Next, I will give this EKS VPC. And this is one of the considerations that you need to make, how many applications are going to get deployed. So accordingly, you need to choose the CIDRs. Unlike the typical infrastructure design, where you say, okay, I'm going to have 10,000 servers and I may need 15,000 IPs give and take. Well, for Kubernetes, you need 1 IP address per pod, per application, per service, per container. So it's like 1:4 or 1:5 IP addresses. So you need to have large enough CIDR blocks for your VPC. So the stack itself will take, I think, 5 to 6 minutes. Until then, I'll finish the rest of the presentation. There is ton load of documentation when it comes to EKS and the design considerations. Some of them I have listed down. I'll put these links in the chat after I finish the presentation. The conclusion, as I will go back and forth with the demo, is before you start your EKS's journey, always make design considerations. Sit with your architect team, or if you're architect itself yourself, sit with Amazon EKS team and engage AWS support team right from the beginning. There were so many instances that we started off doing things and then we had to go back and forth and then engage AWS. So start right from the beginning. I know it is easier, the documentation is there, you start to spin up and all, but engage them right from the beginning. And also understand the shared responsibility model. Like when they say EKS as a managed service, what are they managing? They are managing the control plane for you if you're using self-managed, and they're managing everything with respect to EKS when you're using Fargate or managed EKS. Then when you're moving to EKS, you need to be ready to iterate, do POCs, do some pilots before finalizing on your business critical applications or your VPC design or integration with downstream services before finalizing the architecture. And you also need to pay, like I had stressed enough, to understand the communication that you'll have with the downstream services. And every time you do a POC, pilot, or some sort of a test, document it. It's going to come in really, really handy. And like most of the services that we use on AWS, always refer to AWS's documentation, because despite it being a Kubernetes service, because it is an Amazon managed Kubernetes service, the documentation slightly varies. So do not refer to Kubernetes' documentation and try out and like, okay, Kubernetes says this, well, refer to Amazon's documentation. I can do one thing. Let this guy remain in creating. I can create another cluster in Oregon. I had spun up one cluster. I can just create here another cluster maybe. So the network is already set up. Maybe perhaps I can show you the network, what all it creates. So my CloudFormation creates a VPC, 4 subnets. It creates route tables, and it creates NAT gateway. Where is my NAT gateway? It creates 2 NAT gateways. It creates security groups, which I'll be using for the cluster. So that's essentially what it is creating. But let me just create another EKS cluster for the demo. Create a cluster. I'm going to say EKS demo 2. And this is another thing, deciding on the Kubernetes version. If you are already using Kubernetes either on-prem or on a different cloud provider, you need to be mindful that when you're moving in, go with the same version and then iterate and upgrade. You're on 16 or 17 on your existing infrastructure. Don't say, let me use the latest and migrate to 18. So migrate with the same version that you're having on your existing setup. I am going to use the same, but I don't want to use this. Let me see. CloudFormation is done. And the other design consideration, which I have not included, is on the security groups. You might want to have dedicated security groups for your EKS clusters and dedicated security groups for your downstream services. Because EKS, when you spin up resources, it by default removes all the security groups and allows only what is needed. And this is something that you'll find out from Amazon's documentation, and they recommend that you have dedicated security groups. Information, Virginia. Okay, so this is done. Mohammad, let me know how we are doing on the time, and if you want me to stop, I can anytime, because this demo is not important.
Yeah, you can start. So we have a couple of questions from Nalin, if you can answer. So the first one, he's saying how service discovery works for you among different applications in multi-tenancy.
Right. You can have multiple ways of doing service discovery in your EKS cluster. Either you can use the built-in behavior of your EKS cluster. That is, they communicate with each other using service endpoints. So that's how it works internally for service discovery. Or if you're using Fargate profile, you can let those communications go through your load balancer. So it depends on what type of EKS deployment you're doing. Self-managed, or are you going to use managed EKS cluster that is using Fargate? I hope that answers your question.
Yeah, I hope Nalin that answered your question. He has another one as well on how to migrate the new APIs, for example, deployment when you upgrade the cluster.
Right. If you're using any of the deployment tools, like if you're like most of businesses which have CI/CDs set up either using tools of your own, maybe if you have Jenkins, that's fine. If you're using AWS's tools, all the code, all the deployment code is already checked into your version control system. You can integrate your EKS with those version control systems, and you can perform deployment either using your Helm charts, or you can use AWS CLI or your native CI/CD pipeline communication. So you have multiple options there also.
Cool. So Mahboob, this is the fun part now. You can ask like a question and let the guys answer in the comment and let them give them some free credits.
Sure.
So yeah.
Okay. I had described in the beginning that some of the objects of Kubernetes, I use one term called daemon set and other thing called replica set. So is there a difference between daemon set and replica set? It's a question for everyone on the call. If yes, what is it?
Okay, we have answer from Nalin. He's saying daemon for each node.
And replica set is for?
And replica set control how many pods will be running.
That's correct.
Ah, nice. Okay, Nalin, please leave your email and we will email you the credits code. Okay, do you have any other question, Mahboob?
Yes, I have. Yeah, I have. Is there a versioning for EKS as a platform apart from the Kubernetes upstream Kubernetes version? Let me repeat the question.
Yeah.
Is EKS having its own version apart from the upstream Kubernetes version?
So we have answer saying no from Nalin, already won. Vinet, hopefully I said your name correctly. He's saying no. So Mahboob.
It is not. EKS has its own version. EKS as a platform, and Kubernetes upstream has its own version.
That's awesome. Okay, please leave your email as well, and we will message you and email you the code for the credits. Any other question for Mahboob, guys? I think that's it, Mahboob. Thank you so much.
Hey, thank you, Mona. Thanks everyone for being patient with me. I hope I didn't bore you to death.
We really had fun. Thank you. And of course, we will have with the next speaker some questions as well for the free credits. And in our networking session, if you have some ideas to improve the community, we will give some free credits as well. Sure. So let me just share quickly my screen now. Okay. Okay. So before we jump to Fabian from AWS, who will share what's new in AWS, we usually have hiring announcements. Today we don't have any, but if your team is hiring and you are looking for some talented DevOps or solution architect or cloud architect, please scan this code and fill the form, and we will announce it in the next meetup. And again, we go to Fabian. Fabian, who was just asking the question to Mahboob. He's like supporting a lot in the AWS user group and the community. So please ask him a lot of questions if you have any related to AWS. So I will pass it to you, Fabian.
Thanks, Mo. Thanks for finally giving me the chance to speak, man. Really appreciate that. Yeah, and thanks so much for having me today. You know, it's so good to see everyone here. It's been a while since I actually spoke in the UG. I think probably the last time, maybe early this year or probably last year. You know, COVID-19 has certainly actually threw a lot of things out of whack for me. So let me quickly just share my screen, and I'll do a quick introduction, and I'll just cover you all, you know, what are the new things that's actually happening in AWS. So let me see. Okay. Now my turn to ask. Everyone able to see my screen?
Yes.
You're good. You're good.
Awesome. Okay.
We see your presenter view though. You might want to
Man.
just swap displays. I think that should do.
Okay, wait. Swap displays, eh?
You can just start the presenter. Yeah.
Let me see. No, right?
And on top, just click on the swap displays. That should do.
Okay, got it. Not
All right,
familiar.
there you go.
All right, awesome, man. So is everyone able to see things clearly now? All right, cool. So quick introductions. So I'm Fabian again. I'm a senior solution architect. I've been in Amazon for over 7 years. You will see me popping in and out in the user group from time to time. First and foremost, I am Malaysian. I am in Malaysia, and I am apparently in a red zone right now. I am in Damansara. So I was just looking quickly at news earlier. I don't know what's going to happen, but very, very interestingly, we are going through challenging times. So my background is I have worn many different hats. Been a software developer, big data engineer, systems development engineer across over the tenure of 10 years in IT. And just letting everyone know, in case you have similar kind of interests, I'm really, really into outdoors. Hiking, camping. I'm really into board games. I do have a massive collection of board games. Whenever I tend to actually go overseas, I will definitely get something. And in the night, I do a lot of reading, and I do actually make it like mandatory for myself, at least 20 minutes a day reading things outside of technology, because my world does revolve around technology. And so moving on, I'll be covering some exciting features that is actually newly launched this month. And for those that is actually following AWS closely, you will, when you think about it, you will likely be aware that the pace of innovation these days, especially when it comes to technology, is really fast. And I think just last year itself, there were more than 2,000 features launched. And if you do the math, within a single month itself, there could be potentially 100 or 200 plus features. So given that I just have a couple of minutes here, I shrink that all the way down to just 8 to 9 features, and the focus areas of focus that will be on criteria such as being able to deliver quick to market. On top of that, being able to enable customers or users of AWS to have better operational efficiency or reducing costs in general. So first release I want to talk about is the AWS Lambda's extension and AWS Lambda Insights. So if you are actually a Lambda user, can you just put a +1 into your chat box window? Yeah, okay, so a ton of Lambda users here. And Lambda is actually a very popular one, right? And one of the feedbacks that we've been getting from customers is that what's going on within Lambda? And let's just say that you run into various kind of operational issues. How do we go about troubleshooting? And at this point of time, I've spoken to many different customers, and they do actually have a lot of difficulties. And that's the primary reasons why we actually launched Lambda Insights. It's public preview, and what this new feature provides you is the ability to get more in-depth metric, like for example, memory utilization, network in, network out. There is quite a number of new metrics that we do expose, that can actually tell you perhaps you are having a memory leak issue. Now, on top of that, to complement this new feature, we also launched Lambda extensions. Now, this is very, very exciting for me because over the years, we've been hearing from customers that if I have my own monitoring tool, like for example, Datadog, or perhaps I have AppDynamics New Relic, can I use that monitor Lambda. It is possible, but you'll see that it is a bit clunky. Like the integration isn't great, and that's where we actually launched this new API layer, right? That enables us to integrate seamlessly with third-party monitoring tools. Next feature I want to talk about, AWS Amplify, being able to import existing Cognito user pools directly into your Amplify projects. For those that's not familiar what Amplify is, it's essentially a suite of developer tools designed to simplify application development on AWS. So just think of it this way: you're new to AWS, and you are well aware that AWS actually invests or launch new services across many different technology domains, like, for example, AI services, API-based services. To learn all these things individually can be very, very challenging. So what we have done, for Amplify is that we are giving you tools to provision serverless infrastructure all via a toolchain, like CLL toolchain. Another one is AWS Amplify Library that provides very higher level abstractions that enables you to integrate with these services, more seamlessly. So one of the problems that we have with the AWS Amplify, while developers are very, very keen to use, is that they are saying that we are using Cognito. Cognito is an identity store. If you have a project where you have to build capabilities such as sign in, sign out, sign up, you will know that it can be quite tough to create, an application that uses that. So Cognito actually simplifies that. But one of the problems we have is that imagine you already have an existing user pool. You won't be able to use that with Amplify. You probably need to do a lot of hacking, get it working. So we launched this new feature. Now it's actually seamless, this integration. So give it a go. If you already have existing, Cognito user pools and you think that Amplify can actually allow you to accelerate your development, try this out. Next feature I want to talk about is AWS Glue. For those that's not familiar with Glue, it is essentially serverless Spark. Okay, and for those that don't know what Spark is, very, very popular general distributed processing framework in the analytics world. Now, one of the feedback that we get a lot, and I've experienced it myself, is that startup time for AWS Glue for every single run may take 10 minutes because under the hood, we are provisioning a cluster. So we have essentially AWS, the Glue team, what they have done is they have revamped the entire service, made it 10 times faster, and also changed the billing model. So instead of a minimum 10-minute billing, which can be very expensive, imagine you're running a job that just lasts for 1 minute, and you're being charged for 10 minutes, that isn't really fair. So what we have done is we have completely changed that, but not only that, we also want to allow developers that wants to do local development in their laptops possible. So you'll see at the bottom, I have a blog link. If you are writing data processing jobs and you think Glue is a nice fit, and you think that, hey, like it's a bit expensive as well, do check it out. We have actually launched containers that enable you to do local development on your laptop. Now going into ML tool releases, we have Amazon recognition, in a nutshell, computer vision as a service. Now, this days, COVID-19 season, detecting personal protective equipment is a norm. You will see a lot of applications built on that. So if your business, have a need for that, check out Amazon recognition. It's as simple as just forwarding or uploading an image, and within that image, we can tell you whether do you have a face cover on, do you have head covers on. Very, very seamless to use. And on top of that, we do provide you with a confidence score. Another feature for Amazon recognition, why I like this a lot as well, is because computer vision is really the new kid on the block. Everywhere you go, you see applications, software that is doing things like number plate detection and whatnot. So we have actually launched another new feature, which is content moderation. You see new categories added to it, like if there are any kind of possibilities that there are drugs, tobacco, alcohol, gambling, rude gestures, behavior within the image, it will get flagged out and you will be aware. So very, very easy to use as well. Again, just uploading your image. Another new feature, CloudFront. And this is basically our content delivery network. So this feature just launched 2 days ago. If you are already a CloudFront user, or maybe you are using a third party, and one thing that you're trying to do is you're trying hard to increase your cache to hit ratio, try this out. We call it Origin Shield primarily because we are creating a centralized caching layer just after the origin. So just imagine that the way how a content delivery network works is that me as a user, let's say I'm relying, you have deployed an application on CloudFront. Me as a user will actually be directed to a local point of presence. So in KL, we do have one. It's in AIMS. And essentially what happens there is you go there. If it's cache, then you get a response. If it's not, what happens here is that it gets forwarded to origin, right? But when you go to origin, usually it is typically whatever content you have is served over from the disk, unless you have already provided some kind of caching mechanism. So what we have done here is that we just put in a centralized caching mechanism, and the intent is to reduce the load on your origin, and that's where the name came from. And just a quick depiction how that actually works. Front layer, point of presence, I mentioned, AIMS KL. This is where the edge locations are. In between, those that are familiar, you know that we do have a larger regional edge cache. Essentially, this is a larger capacity in terms of memory, and all the way to the back, you have Origin Shield, which is basically this centralized caching before you hit the origin. In this case, this would be elemental media package. And next one, compute release. This is actually a very big one. This is essentially the ARM-based virtual machines that we made announcements late last year. This is GA in Singapore. And from our performance benchmarks and also working with customers, we have data points that show that it delivers 40% better price performance against the x86 processor architecture. So if you are already, you are using an M5, you're using an M4, do check this out and consider to migrate over, because you will be paying less. But not only that, you are going to get better performance. Okay, so we have been launching, rolling out the Graviton. Essentially, we call it the Graviton machines across all our services, from Elastic Cache, RDS, EC2, you name it. Because we are getting so much positive feedback for it. And database release. Just calling this out, I like it a lot, is because this is the first time I see a feature where we do auto storage reduction, when you're not utilizing the space. If you're an Amazon RDS user, you would be aware that whenever you actually scale up, because let's just say that you have a need, storage requirements go up. And later point, when you delete, and let's say your data, what happens here is that the storage will not be able to shrink. And let's just say that it's costing you a lot. What normally happens, you need to actually migrate across. So for Amazon Aurora now, we are just going to make that whole experience for you seamless. We will reduce the storage space automatically for you. And that's all from me. thanks so much, guys. And let me know if you have any questions.
Awesome. Thank you so much, Fabian. Guys, just a reminder that Fabian is on our Facebook group. So if you have any question, hit it there and he will help you as well with the community. Thank you, Fabian. Okay. Let me just share my screen quickly. Okay, guys, so before we start with our next speaker, I just want to share that you can give a talk in our AWS user group meetup. You just need to scan this QR code and fill the form and we will reach you. So please, if you are building...
Mo, you might have to share the screen.
Oh, okay, let me just share it quickly. Yeah. Is it good now? Yeah.
Yeah, we have it.
So yeah, this is the QR code. I will share it later as well on our Facebook group. So if you are building some cool stuff with your team or just for fun, please come and give a talk. So our next speaker is Abdullah. Abdullah is from ServiceRocket and he's a full stack developer. And he will talk about video on demand solutions with AWS. I will pass it to you, Abdullah, from here. And I will stop sharing my screen. You just need to unmute yourself first.
Hello, good evening. How's the voice?
Yeah, it's good. Yeah, I can see your screen.
Okay. So I'll be talking about getting started with a video on demand service using AWS. And my name is Abdullah, and I'm a software engineer at ServiceRocket. You can find me on Abadev at Twitter. So I work in a team as well that has...
Sorry, Abdullah.
So yeah.
The voice is so low. So can you raise your voice a little bit?
Sure. How's it now?
Much better. Thank you.
So I work in a team that has a video product, but what I'm presenting here today is from personal learning. I have a disclaimer that I'm not a video engineer because I will touch on some video stuff. So some of you who might be quite strong in this video domain, please bear with me. And I would love to hear from your comments as well, questions, if in case we'd like to go to somewhere deeper. So the contents I'm talking about today is, the first one is intro to video on demand and a bit of video basics. And I want to touch on concepts about the challenges in video delivery. And we'll talk about mainly AWS Media Convert. What is it and how, and we'll do a demo on that. And the last part is generating subtitles with AWS Transcribe. So video on demand, quite briefly, I mean, it's not just about movies or Netflix. Video content is everywhere, whether it's e-learning content, corporate promos, social media, and recently, because of the situation, a lot of more Zoom recordings are being stored and created in the cloud. So I wanted to phrase this presentation as if you are having a challenge here. You're a start developer who just been hired by the startup founders, and they decided that the next product is an e-learning product called Udezilla. And they just asked you, come on, build the video platform. Anyone can upload a video and anyone can stream the videos on demand. So when you start, you would think, where do I start on this? And probably the first question is, can I use YouTube? But YouTube doesn't feel like a premium service that you would offer as a company. And when you look more, you come with a lot more services here that are, some of them give you ready-made services and some of them sort of give you APIs to deal with. So your deciding factors here would be, of course, on pricing based on expected usage and how easy it is to use. And what I call that is the hand-holding, how easy it is for documents. And my experience is when I was starting to research a lot about this, the hand-holding in some websites is not great at all. So we would be talking about AWS and consider these on the side for now. So if I would use AWS, and I would think, okay, my uploader would just put the video with using pre-signed upload to my S3 bucket. And I would put a CloudFront CDN in the front, and have an HTML5 video. So I assume the video can be an MP4 format. But the question is, the challenge that we're facing now is browser support, because most of us think that a video is an MP4 file, but MP4 is actually just a container. So think of it as a box that stores video and audio data and even subtitles. So the video data is compressed using a compression technology, and we call these codecs. So the most popular one is H.264. And there's other codecs that also give you an MP4 format. But you would ask, which one should my user choose? And of course, you can't tell the user choose this or that. And if you see the browser support for H.264 is okay, actually. But for H.265, it's very bad, even though H.265 is intended to succeed H.264. But we're not there yet. So for example, here in this demo, quick one, that I have two videos. They're the same videos. Both of them are MP4, and one of them is the other codec that doesn't work, and one of them works. So this brings us that we do need to have a transcoder, so we can output the right format. And we also support more input formats such as .mov, .quicktime, other stuff that our users can generate also from other cameras. So this brings us media convert, which we'll be talking about shortly. And what will happen is that the video will come in, we'll take it to media convert and output it to a bucket, and with the same flow as before. So I have a question, actually. I can't actually see the chat because my full screen, but it's a question for the AWS credits. What other service can you use to transcode videos as well?
Nice question. Maybe you repeat the question again, Abdullah, for the people.
So, what other AWS services can you use to transcode videos? The answer might have popped up, by the way, suddenly.
Okay, we have Hussein, Elastic Transcoder.
Yeah, that's actually the correct answer.
Nice. Hussein is from AirAge, yeah. Okay, I know your email, Hussein. I'll send you the credits.
So the other transcoder is actually Elastic Transcoder, and it's good enough for simple workflows. I won't touch on it, but it can be used for some basic workflows. Actually, that's what we use in our current video product. But I'll be demoing on Media Convert and to show you a bit of the flexibility this offers. So we have to come to the second challenge, which is the challenges in streaming. And the main one is, of course, buffering. So my second question here as well is, in what ways can you reduce video buffering problems? So this is probably a general software engineering, video engineering. Do you have any answers? Any comments?
Yeah, we have delivering lower quality depending on user speed.
Do you have a word for what does that mean?
Internet speed?
What I mean, like delivering the lower quality video depending on the user's internet speed.
Okay. Yeah, I will touch on that actually. That's actually quite good. I will accept that. We'll dive deep into this in a minute now.
Nice. Please leave your email in the chat.
So so buffering is due to video size. The issue can happen is because if you have a video size that is 1280 and it's the same file size for all devices. So if you have a big TV, it's actually going to be small, blurry. And if you have a laptop, that will look okay. And if you have a mobile, it's actually too large and it will also buffer. So one of the things we can do is, as this person mentioned, sorry, I couldn't read your name here, is that we would create multiple video sizes. So we'll tell Media Convert, hey, when you create multiple video sizes for all these, and we'll put them in the output bucket. So we can serve everyone depending on their size. Sorry, I clicked. The problem is not fixed yet. I mean, we are reduced to 144 or whatever, according to this meme, but it's still buffering. Because there is an issue, and internet speed can change while you're watching the video. So even if you have MP4, if your player requests this MP4 and we request a lower quality one from the beginning, or for example, we request a higher quality, and then in the middle, the speed goes bad, we will still be downloading the previous one. So here's a demo for this. So for example, we have these three video sizes. And the ideally is, why don't we break them into smaller sizes or segments, parts, so that within the same stream, we can actually pick a lower quality one from the same video. So if you have fast internet, you can get the video size of this one. When you go to the slow, you'll download the segment from the same video, but a lower quality. And when you go back to fast internet, you can get the higher one. And we all experience this actually, where when you use, for example, YouTube or Netflix, and when it goes very bad and you try and force it to stay on a certain resolution. So we call this adaptive streaming, and this is the ability to adjust video quality in the middle of the stream as the network conditions change. So there's two formats for this. So before we discuss MP4, but to do adaptive streaming, we have two formats called HLS and Dash. And they're rival formats. HLS is by Apple, and Dash is a new format, and it's actually becoming the standard. HLS has more browser support, though. So they both split larger files to smaller segments. Each segment is usually 10 seconds. For the HLS, file extension is .ts, for example. And for Dash, the segment is 2 to 4 seconds, and file extension can actually be also MP4. And they both create a manifest file. So when you put in the video player, you'll put the manifest file instead of all those individual files. And the playlist, it's actually a playlist, which knows which files to call depending on the minute you're watching. So the extension for HLS is M3U8, and for Dash is MPD. So we're asking Media Convert create multiple video sizes and formats. So we're creating here video segment 1, video segment 2 from the same size as well. And we also create a manifest file. So I'll go to a demo. This is a demo that is actually pre-recorded. So I've cut some of the time that it takes to open stuff and run stuff. And it's a video already integrated here. So going from the Amazon console, what you can do is, when we scroll down, we have media services, and there are these different services offered by AWS for media. And there are different use cases, whether it's live, whether you're running a broadcast company and you have ads, and whether you have other stuff. But the one we want to focus on is Media Convert. So when we come to Media Convert, we open it, we see this. And what we have here what we see is a jobs place where we can create a normal job. And there's other places where you have output presets and job templates. So job templates can help you create templates for future jobs, and presets allow you to customize how you want to do the codecs. Queues as well. So if you have a lot of people uploading at the same time, or you have a lot of workflows happening at the same time, you can configure up to different queues and configure which one has priority. But we'll focus on just creating a normal job on a default queue. So if I create a queue here, if I create a job, I mean, and what I come here is, we need to focus on this side, which is inputs and outputs. As simple as that. So first of all, we're going to create an input. And I've already uploaded a video to my bucket. It's a normal MP4 that I used Adobe Premiere to export. So I selected the video. And this is my only input. There's actually a lot more settings here, but I don't have to do any of this. And this is the part where I mentioned. This is the part where I mentioned that. Sorry, I skipped by mistake. This is the part where I mentioned I'm not a video engineer, as in there are some settings where you actually need to employ someone who really understands in depth what settings, what fixes do you need to do, and what presets do you need to use. So let's move to the outputs. So as you can see here, we have different outputs, and we have HLS and dash, which we mentioned. And you also have file group. And this file group means you can just create a normal MP4 file. So I'll select dash for this demo. And we have an output group. So it's like a container, and then we define what's inside. So I'll just create a name for this, and I'll define the path, which will be also in my S3 bucket, but also in an output. In production environment, maybe you can have different buckets for input and different buckets for output. So here I'm also defining segments, because we said we want to have it segmented. And I can actually define the segment length. For this demo, I put 10 seconds. And then when I come down here, so this section, I define the outputs for each of my dash output. So when in dash video, you actually need to split the video data from the audio data. So I'm creating a separate output for video only. And I'm also creating a different resolution here, which we'll configure in a minute. And I'm also creating a separate output for audio only. So I'm creating two resolutions for this demo. Audio doesn't have to be a different resolution, it's the same one. So now when we go to, we'll have these three groups created, as you can see here. So what I'm doing is I'm going inside each one, because each output will come by default with the video and audio. So I'm deleting the audio from the video part, and I'm deleting the video if it's an audio. So this is audio, I'm deleting the video because I just want to keep each data stream separate. Now you might be wondering, okay, what are we doing here? Here you can define the preset. So if you've worked with Adobe Premiere before, this is where you select the bitrate and all of that and what maximum quality you want. You can have a preset here selected by system presets that's available, or you can do it yourself. So I'll do it by myself here. And I'm creating an output which is exactly the same as the original for now. And the other thing, you don't need to worry about all of these. These are all video engineering in depth, whether they're related to frame rate and quality. And it depends actually on the input you get and the type of tuning you do. But what you need to fill is only the bitrate. And bitrate is the amount of data in a frame and how much data gets transferred. And for this one, I put 6 million, actually 6 megabytes per second. I can put something less, but I can't put something more. And this video was created with a 10 megabyte per second. So what it means is if you have a 4K, it would be a very much higher bitrate. And if you have a very low quality video, it will be much less. And it defines the size of your video, basically. So I'm also doing the same for the other resolution. I'm just defining a smaller resolution. And I'm defining another bitrate here, actually a lower one, since it will be less resolution. I actually chose these arbitrary for the demo. I should have probably used the guide to help me and select the right one, but I just wanted to demo that how quickly to get. And for the audio part, we don't need to demo anything. We don't need to change anything. The default are okay. It will create an MP4 output for the audio. So we come to the settings, and I need to define the default queue. And I give it the default role that we need to create, which will give it access to S3 bucket. So what we can see here is the status update interval is, oh my God, is because Media Convert will send you the data to, where was it? Yeah. This is the problem with doing pre-recorded. You get lost. So it will send a status event to the CloudWatch. And here you can define the interval basically, because if you have a very big video, it might take forever and you want to know whether it's an error or if it's actually still progressing. Here you can add metadata or tags, and other stuff are actually for on the pro level. And the pro means that you will actually pay more for the Media Convert pricing. And the pricing here is by a minute of encoding. So I submit it, and when I refresh, I can see that it's progressing. And it's completed. I mean, I'm skipping here, of course, it wouldn't take that much. It actually took 1 minute and 10 seconds. So now if I go to the S3 bucket and I go to my output, I can actually see quite a lot of files created for me. And because we've created different segments. And what I need to do is copy the playlist output, and which is the first one with the .mpd format. So I'll go to a demo player. I used Bitmovin. You can use, there's quite a few Dash players that you can play online. And I just put my link here to test it, that it's working. And it's should be loading fine. And you can see here that we can have the different qualities that we've actually defined in our transcoding. So back in the job summary, you can see a Vue.json. So Vue.json is to get actually the whole configuration that you've done. You can actually download it as well, export it. And this JSON is actually your template that you can take in your code to modify dynamic variables. And then you can trigger a media convert job from your own, from your Lambda, for example, or from your app. And you can also duplicate, so you don't have to keep doing everything again, and you just change certain configuration, especially if you're testing. This is quite useful. So talking about video players, you notice that I tested it on a Bitmovin player, but I didn't test it on the normal HTML because native HTML5 video won't work with HLS or Dash. HLS has some support. So the solution is actually JavaScript. And there's quite a few open source players, and some of them are not open source. Some of them are actually paid services, such as the JW player, Bitmovin, and the other two. But the main ones that we work with would be Vue.js. That's very popular, and also Chaka Player. Chaka Player is by Google. And for example, in Chaka Player, it's not hard to integrate this in your code. I mean, this is HTML, and you also have a video element. It's still under the hood a video element. And you just bring in the JavaScript for the Chaka Player, and then this is where you define your URL, and you'll just initialize the player, the Chaka Player, and it will initialize for you. So this is the flow we saw before, the architecture flow. We have the S3 bucket and going to the media convert to the output, and then the CloudFront. But if you're building an app with in production, we'd probably need to do this. We would need to listen to the bucket from a Lambda, for example, or your app. And let's persist the data. And what this Lambda will do is actually get the video metadata, define what source it is, what bitrate, and what's the quality of it. Based on this, we put a job, and we define the job manifest for the media convert. So we say, and then we update the DynamoDB that we triggered this job status. So the media convert will start pulling the source and outputting the video. And when it's done, it's going to also send status updates to CloudWatch events. And what you can do is trigger another Lambda from CloudWatch events to update your DynamoDB to completed. And also do other verifications if you want to on the output. So then your manager comes back to you and says, our customers want auto subtitles. So let's go back to the flow. How are you going to implement auto subtitles here? Well, what we can do is when we define media convert is tell the media convert, please output another audio file as a separate one. We can put it in a temp bucket as well, or a temporary path. And then the Lambda that will check when the job is finished will trigger a job to Amazon Transcribe. So the breakdown of this job is that when the Amazon Transcribe is triggered, it will grab the audio file that we've defined, and it will output a JSON. Because Amazon Transcribe will listen and output in JSON format, which I'll show you in a bit. So you can listen to the S3 bucket as well again, and have a Lambda that will run a conversion to a subtitle format, which is a VTT or SRT. And then you can place the subtitles file back in your video output bucket where your video media is, so you can grab it all in one go with the player. So here's a demo as well. And I have run quite a few jobs, so I'm just going to duplicate one. And this big bunny doesn't actually have any voice, so I'm going to replace it with one that actually has some recording voice. And what I'm going to do is I'm going to just change the name of my output, and I'm going to add another output, which is a file group. So when I come to the file group, I will just call this audio only, for example, and I'll put it in a different path as well. And then I go inside the audio file and just remove the video. So it's 100% audio. And it's an MP4 audio only. So I'll create this job. And I can see that it's being created. Yes, there's the MP4. So I go to AWS Transcribe. And I can create a new job here. So I'm going to choose general model. I don't have my own model, and I'm going to choose the language as English. And this is where I put the name of the file. I'm going to define my output as well to be my specific bucket. I'm just going to put it in the same folder as the audio. Here you can also do more configuration if you want. You can also add some custom vocabulary. So after a bit, it will finish, and you can see the file and open it. And it will look like this. You have the transcripts, and it will have start time, end time, and it will split all the text that it grabs based on time. So here, I mean, I don't want to go in the code a bit, but basically the function that will take it, the Lambda, will just use a library for me, and then we'll take the JSON. And we'll convert it. I actually found it online as open source, and I converted it a bit, modified it. And when we convert it to a VTT, this is how a VTT file looks like, in case you're wondering. And it's like a normal SRT file, time and text. So this is the output. This is a previous video. And actually, this is created by AWS Transcribe. And when I add it to the player, and this is how it looks like in your video. So this is most of the concepts I wanted to cover, but you might be wondering, okay, this is a difficult architecture or a bit too much. How can I easily start building it? So there's two ways you can start. Actually, there's a video on demand workflow that is in an AWS solution implementation. They have a page for this and some video. I haven't implemented this myself, but what we described is actually almost similar, except they're using AWS step functions. But the nice thing is that they actually give you an implementation guide, and they also give you a CloudFormation template. So it should be a one-click, and you should immediately have this deployed. It will cover everything, and they will cover media convert, and it will also cover your CloudFront and your S3 bucket. The other way you can also start is using AWS Amplify. And AWS Amplify has been available for a while, but they also have recently added AWS Amplify Video, and Video on Demand has become out of beta. And this is a blog post from just a few months ago. And it's quite simple actually to launch immediately, and it will have out of the box, will launch for you these video processing and also Amazon Cognito and the data management system that you can also configure. I won't deep dive at all in this AWS Amplify because this is a whole another talk by itself, but it simplifies it a lot, and it's just as doing in the Amplify video ad. So to recap on everything we've discussed, I discussed a bit on understanding video on demand, and we went on the video basics and what are the challenges of streamings and why we need to do transcoding. And we talked about adaptive streaming and also other players. And we described in detail how to use AWS Media Convert. Then we also talked about a workflow using AWS transcode to do auto subtitles. Thank you very much. This is my talk and exactly on time.
Thank you so much, Abdullah. I really like the slides with the meme, man. It went really smoothly. So I just have a quick question, actually. How much cheaper is Elastic Media Convert comparing to Elastic Transcoder?
Good question, which I should have researched.
Yeah, actually, I had this discussion before with Abdullah, which is like an expert with the Elastic transcoding videos and all these things, and we found that actually Elastic Media Convert is much cheaper than Elastic Transcoder if you go with not the premium level. So it's like almost half price. So that's why in Astro we switch from Elastic Transcoder to Media Convert, and even AWS actually on the documentation right now they are recommended.
Yeah, they are recommending Media Convert. I haven't looked in the difference prices, even though I should, because our product is using Elastic Transcode, and we should probably convert to Media Convert as soon as possible.
Yeah. So if you go with the basic tier, you save almost 50% of the cost, which is like huge in my opinion. So that's a cool thing actually. So any question, guys, to Abdullah? Do we have any? Absalam, do you have any question, as you are the video expert and doing all the streaming for our user group? Absalam is sleeping. Okay, I think we don't.
I have a question.
Yeah, please go ahead.
The question is like, what about the security? Like, if I want to have the media in my, for example, learning management system, so I want to make sure that only logged in users can watch those videos. So how do I make sure with this model?
Sure. So there's two types of security you can do in video on demand. And the one that you can easily do is CloudFront pre-signed URLs or CloudFront signed cookies. But the trick here is you're actually going to just limit the playlist, but you need to keep the segmented files public. Because the segmented files, if you downloaded them themselves, the player wouldn't actually be able to load them properly. You need the playlist that knows where to grab these video parts. So I was thinking about this. How can I configure this on Media Convert? And I haven't answered that question. Well, what I would do is put the playlist on a separate path, so I can define a separate behavior on CloudFront, and then put the segmented files on a path that's going to be public, that is accessible by the CloudFront. So this is one way and how to allow only logged in users access the video. But that doesn't mean if this logged in user, for example, grabs this playlist, and I mean, they can still actually download it. But if your question was preventing even if you download the video, I'm a signed in user and I can download the video, preventing me using it or uploading somewhere else. So there's something that you can do is called digital rights management or encoding the video. So this is an advanced topic. I actually wanted to cover it, but it would probably taken me 20 minutes. But Media Convert allows you to do this, and you would need a third party that would give you some way to integrate this. And so it's a way when your video becomes in CloudFront, your video is actually encoded. So even if I download it, I cannot play it. my player needs to request a license from my app, and your app will request it from this third party, grab and send it back to you. And only at that moment you can play it. So that's what actually the technology that is used by Netflix or media companies that need to protect their content.
Okay, thank you. I was interested to know about the basic security. Yeah, thank you.
Awesome, Arafat. Thank you for the question. Any one more question, guys, for Abdullah? So we have one from Sam. I think Sam is the
yeah, I saw it. AWS Transcribe doesn't create SRT natively, just VTT. Actually, AWS Transcribe creates a JSON file, and because you might use it in different ways, whether it's actually speech to text, so you might have a lot of workflows that use this. I use the library to convert it to VTT. I probably can find a library that uses to SRT. I don't know why I use VTT, because I had SRT issues that day. So yeah, it's just a Lambda that will just convert the JSON to that format. It's not related to AWS Transcribe at all after that.
And you have another question actually from Ariful. If you want.
Can KMS encryption be integrated for video security? So yeah, this is another type of encryption. If you don't want to go for digital rights management, you can go for normal encryption. I know that Elastic Transcoder even supports this. Yeah, definitely you can do it with Media Convert, because Media Convert has much more power. I haven't done this type of encryption before, so I'm not sure how to. I can't answer much more on this.
Cool. I think that's it. Abdullah, thank you so much, man, for the great talk.
Thank you for having me.
Thank you so much. Okay, I'll just share my screen to share with you some. Okay, guys. So before we go to end our live session and we go to our networking session, we just we really appreciate if you can just scan this QR code right now and fill up the form later, so we can improve our community. So if you have any ideas or any feedback for our speakers, please fill up the form, and do follow us on all of this. So we have the YouTube channel we created 2 months ago, and we want to reach it to 100 subscribers soon, hopefully. And on Facebook, Meetup, and LinkedIn group, which is new as well, that Kaushik created. Please join us there as well. We want the community to be bigger in Malaysia. And for our next meetup, we have 2 great speakers as well. Saurabh, he's a senior software developer from BlazeClan, and he will talk about API rate limiting and AWS Redis Cache. And Abdullah, he's one of our AWS user group gang who is helping us with all this streaming. And he was leading the cloud team in Seek Asia, and now he's a software architect. And he will talk about KubeCon Meetup Digest and share what did he learn from that. So do join us next meetup, guys, and thank you so much. And so we will stop live on YouTube, and we can just now have a chat all together on Google Meet. So thank you so much again, guys.
Great.